This is the Knowledge Graph Insights podcast, episode number 20. The mix of technologies and hybrid artificial intelligence systems just keeps getting more interesting. This might seem like a new phenomenon, but long before our LinkedIn feeds were clogged with posts about retrieval augmented generation and neuro-symbolic architectures, Jans Aasman was building AI systems that combine knowledge graphs, symbolic logic, and machine learning. Large language models and generative AI are just the newest technologies in his AI toolkit.
Welcome to the Knowledge Graph Insights podcast, where experts on knowledge graphs and the semantic web share their wisdom with the digital and business communities. Our mission is to demystify and democratize knowledge graph technology and practices to make the benefits of knowledge graphs and semantic technology accessible to all. And now, here's your host, Larry Swanson.
Hi, everyone. Welcome to episode number 20 of the Knowledge Graph Insights podcast. I am really delighted today to welcome to the show Jans Aasman. Jans is originally started out as a psychologist, and he got into cognitive science. And for the past 20 years, he's run a company called Franz, where he's the CEO, doing neuro-symbolic AI. So welcome, Jans. Tell the folks a little bit more about what you're doing these days.
Well, we help companies build knowledge graphs, but with the special angle that we now offer neuro-symbolic AI, so that we kind of, in a very fluid way, mix traditional symbolic logic and the traditional machine learning with the new generative AI, right? And we do this in every possible combination that you could think of.
Yeah, and
these applications might be in healthcare or in call centers or in publishing. Many different domains it applies.
Yeah. Is it mostly like large enterprises, or is there a certain scale at which this stuff works better, or?
Well, our customers are always Fortune 500, Fortune 100 companies. It's all the companies that are trying to do innovation, right? And most big enterprises now believe that knowledge graphs is in their future, right? And they're experimenting with it, and then they do experiments, right? And we help them build their first knowledge graphs in most cases. And once they get that going, they can do it on their own.
Interesting. So it's often their first knowledge graph. Where in the organizations is this typically pioneered? Like, as you come into an organization, is it IT or is it data science, or where are you typically entering the organization?
That's actually the wrong questions. The thing is, all the places where we're successful, there's a person that's really looking into the future, right? And has this vision that it's possible to not build a new silo for every new problem, but there should be a way to integrate all the knowledge in the organization and do something incredibly useful with that, right? But you can't leave it to a single programmer or a single architect. It's usually someone with some business experience and also some architectural role that believes in this approach, right? And but if you leave it up to an IT department, it's just another database, right? But it's not the philosophy of a knowledge graph of integrating knowledge. It's just, okay, well, this is a problem I can solve with the graph. Let's do it that way, right? You need a person that says, hey, I got so many different sources of information in my organization, and I know we're not combining it in the right way, right? And it's too complex to put in a relational database. I know we need to do, we have to solve it with a thing that they now call knowledge graphs, but it's even more than that, right? I know partly it's data science, it's machine learning, partly it's rule-based, the logic, symbolic logic. And I also know that I need the new generative AI in this, right? So, but how do I do this all, right? This is incredibly complex, and I can see the future, but how do I do it? Right, that's where we come in. I'll build them knowledge graphs with the symbolic angle.
I love that, and that knowledge graphs are a key element in this the architecture of the future and of the present. I mean, it sounds like, yeah. How do you? So is there I guess that champion who comes to you? It sounds like there's somebody who's been aware of the hazards and consequences of siloed information and data. Is that typically what they're coming in for? Of like, how can we get how can we better integrate and understand all of this?
Well, again, I would say there's two types of champions, right? One of them is just they want magic, right? They see all the articles about generative AI. They see the Gartner articles about Forrester articles about knowledge graphs, right? And they think, oh, well, I have the feeling that something can be done with knowledge graphs and neuro-symbolic AI, right? So those people are not very super technical. They usually have a technical background, but then went into business, but they know that something can be done. And then you have the second type of champion of people that are literally always over 35, right? That have spent their active life building application after application, right? And every time when they created a beautiful application where the bosses were really happy about, but the kind of sad thing is they built a new silo, right? And they made their whole enterprise even more complicated. So these are the people that say, you know what, there has to be a better way of integrating my knowledge. And those are the people that get interested in semantic technology, right? And they say there has to be a way that we don't build new silos every time. And it's the thing that we call data-centric computing, right? Data comes first and applications need to go on top, but we don't need to change the data all the time, rewrite and copy the data all the time, right? So that's the disappointed IT person says there has to be a better way, right? Does it make sense?
Yes, that makes
One is really looking at the future like, wow, my company needs magic, right, to make more revenue. And the other one is, hey, we need to reorganize our IT house because this is madness the way we do it now.
Yeah, they don't want to do that, repeating the same mistake over and over again.
No, let me try to turn my sound up. Okay, yeah.
Cool. Yes, and you said they're always older, because these folks have been around the block a few times, who come in with that. Are they, I'm going to guess, are they generally, it sounds like both, it sounds like maybe in the first type, the magic seekers, you're probably doing a lot of education, but with the second type, you're maybe just more, finessing the implementation. Is that?
No, it's a huge difference. The magic seeker will give you freedom, right? To think together, okay, how are we going to do this? What is the first baby step we can do, right? To show the rest of the company that this works, right? So, and so you've tried to find the low-hanging fruit, right? Where you can show how neuro-symbolic AI and knowledge graphs can help and do things they couldn't do before. Whereas the second type of champion, the disappointed IT person, right, that says, we have to find a new way, right? Then it's way more IT oriented, right? Let's find 3 databases where we want to do something extra with. Let's build a semantic data catalog, right? Let's build an ontology of the objects that we really care about in our business, right? And then let's see how we can replace an existing system by something that is 10 times more simple, 10 times more easy to understand, and 10 times easier to do data science with, right? Does it make sense? So that second champion is more IT oriented and wants to make the flow within the company better, and the first one just wants more revenue by magic.
Right.
Huge difference in the two champions.
Yeah. And is it pretty much an even mix between those, or do you or do you seek out one or the other or more? Or
No, I mean, you can't cold call a company, right, and try to find a champion. It doesn't work that way. They have to find you. They have to go to conferences to find you, and you have to tell the stories, right? I mean, what is neuro-symbolic AI? What is the use of knowledge graphs, right? And then you give them example stories of what you did for other companies, and then they say, hey, I have something like that, right? Can you do that for me? That is basically how I think all of us in the world of knowledge graphs work, right? You give examples, they look at it and said, hey, that applies to me probably.
yeah, so that's it. Well, that's interesting. And I guess, but in either case, you're going in and you focus on neurosymbolic AI. But a lot of the work we talked last week in preparation for this, and it sounds like a lot of the work you do, there's almost always a mix of logical and neurosymbolic stuff, machine learning, LLMs. Is that bespoke, kind of driven by the needs of each organization, or are there patterns that emerge in that?
It's the latter. It's the patterns that emerged over time, right? I mean, when we started out 17 years ago with the Lego graph, right? It was a knowledge graph, right? A graph database. The word knowledge graph wasn't even invented yet, and we had logic. It was declarative logic, right? And it was so that was important. That instead of writing programs, you had declarative logic. But then we got these things like OWL and reasoning systems, right, on top of OWL. That worked sometimes great, but these description logics, right, that we worked with were really bad with time and place, right? And all the customers I had something that was temporal and it was located in areas. So we added a full Prolog compiler to our Lego graph, or our pre-knowledge graph, right? So now we had a symbolic logic system. But then 10 years ago, I think, actually even more, my first articles about temporal and spatial knowledge I've written about 11 years ago already, right? Because every customer did something with things that change over time, right? And location was often a big part of it. And so I got into this event-based version of knowledge graphs. And of course, what's the most important thing in an event-based knowledge graph? You want to predict what is the next thing going to happen. What is my customer going to decide? What's going to happen to this patient? When is this plane running out of, going to have a problem with a particular part of the equipment? And is it in my inventory? Right? So prediction became important. And so we started working with machine learning. It was a completely natural evolution, right? We started doing stuff with events and in time and place. We wanted to do predictions, and now we needed to become experts in machine learning. So that was great, right? And then about 2 years ago, our world exploded, literally for all the people in our community, right? Because now we suddenly had these generative AI and LLMs. Now, by the way, the knowledge graph people for the last 10 years have been working with unstructured text and using taxonomies to find the important word in your domain, and then use these taxonomies to extract the entities out of the unstructured text, right? And then put those also in the graph. So now you can use logic and even machine learning to work with that. But it still was very, very painfully slow to build these taxonomies and to work with them, right? And then 2 years ago, as I just said, our world exploded. And now we have generative AI. By the way, we still need taxonomies all over the place, but now the generative AI can do things that I never even dreamt about, right? I mean, for example, in the old days, I could say I'm looking at a medical text and I can find the word aneurysm, right? Well, I can find that, but it's fairly useful to just have the term, right? I want to know, okay, does the patient have it now, or was it a little bit ago, or was it in the history? Did the doctor actually say that he denied an aneurysm, or was it actually there? Is it in what stage is the aneurysm? If it's treated, what is it treated with, right? And we became experts in just annotating terms out of documents, right? So instead of just getting a term out, we can say 20 things about how that term fits into the pattern of that particular paper. Now then, obviously, story and this text. And then, of course, it became very important that we can also put things in a vector store, right? So we can start doing RAG, but not just dumb RAG, right? Where you dump everything in a big bag of vector indexed text, but that you actually can do a mix and match of symbolic AI to pre-select where you want to do your RAG on, right? So they call that graph RAG. And so that's yet another thing you might have heard about, but that also became part of the mix. So now, after, say, 17 years working in this domain, right now we have the symbolic logic with first order logic, because we have the full Prolog. We have machine learning, primarily recurrent neural networks for event prediction. We have generative AI for entity extraction and RAG, and even graph RAG, right? So it's like it's blooming, and the whole industry is going in this direction, right? It's just a pattern that's emerging. And by the way, so we call this mixed neuro-symbolic AI, right? I mean, because, I did my thesis in modeling car driver behavior. I'm a psychologist. I tried to model a car driver. I wrote about 2,000 rules to model the behavior of car drivers, and I got amazing results when I compared my model with real human drivers. But I was lamenting in my PhD thesis that we really need neural networks, right, to do object recognition and do pattern recognition, because just doing the rules wasn't good enough. It was too complicated, and it just couldn't do a lot of things. And now it's like 35 years ago that I finished my PhD thesis, and now I wish I could go back, because now I can do anything I ever wanted in my model of a car driver. Does that make sense? I'm going off topic here, but
No, but that kind of speaks to the rapidity, not the rapidity, but the depth of the evolution of these of the tooling here that you could.
Yeah.
But even back then, you could see that like that there's you could imagine like some kind of technology that could help you accelerate that, but it just didn't exist, and you couldn't build it. Is that like. I mean, it's just the way it is. Was it frustrating, or was it just a relief when it finally showed up?
well, it was more like, oh, this is what I always wanted. Does that make sense? This is what I always,
Well, right, because you didn't even know.
No.
Yeah, no, I just.
Hey, I've been doing NLP for more than 30 years, right? So, I mean, in my previous jobs, NLP was always one part of it. And now I still every day can't believe what we've gotten into, right? With the generative AI part.
Yeah. Are there still like, I don't know, old-fashioned, but conventional NLP, like the understanding and generation stuff in these LLMs, or had the GPTs and LLMs just replaced all that?
Oh, no, absolutely not. So, I mean, there's many facets to generative AI, right? I mean, you can ask questions of a text, and it will do really well if you have a concrete text. But you still want to do entity extraction, right? Extract concepts out of a text and link them to your company determined taxonomy, right? So it's still important that you have a list of all the things you care about in your company, and then take texts and relate them to the terms you find important. Because doing RAG on 1 billion documents without pre-selection of what you actually want to look at gives you, well, very, very bad results. So you still need to pre-process texts. Just imagine, right? You have a billion documents. Sorry, a billion emails, right? Between people in your organization. And at some point you say, okay, find me all the meetings that were canceled due to COVID between this group, this project group, and that project group, right? Well, you have 1 billion emails, and you have that question, right? You can use RAG, right, and talk to your to the email, and you will get a really bad answer. The chance that you get the right answer is almost nil, because what you really first have to do, okay, what does it mean that you're part of this group or that you're part of that group? So let's only select all the emails from these two groups, right? And then let's look at the time period where this happens. So now you have to do a time selection on the data. And then you can start doing maybe first another selection of the fact that there was a meeting request, right? Or something about a meeting. And then you can start doing RAG about which meetings were canceled due to COVID. Now you get a really good result, right? Because you did a lot of work with symbolic logic just to pre-select, right, the domain in where you want to look. Because otherwise, it's just how do Americans say, that's a shotgun approach, right? And you hit something, but you don't know if you hit the right thing.
Yeah, that's really the way you just said that. That's super interesting. That like, well, it kind of gets into use cases for just AI in general, but then like the how you would tackle that, like that particular use case.
Yeah.
How has that evolved? Like, so that sounds like that particular use case might not have changed that much with LLMs. Maybe there's some.
No, but it makes a big difference, because now when I do my RAG, I only look at the texts, right, that contain any word that resembles meeting, right, that were between someone from group A to group B, right? And then I do my RAG within that subdomain, and that works. But also, I have a database with about 500,000 clinical trials, right? And I say, give me the negative of effects of ibuprofen if you are already using aspirin, right? Well, there's 40, 50 years of clinical trials, and it's kind of nonsense to ask this question because there's too many articles to look at, right? But if you really, really can do a pre-selection on ibuprofen-related drugs, NSAIDs, and aspirin-related products, right, and then find a much smaller subset, then the RAG suddenly becomes very viable and useful.
So it's more, yeah. So that's a really good example of that kind of architecture where you do that machine language pre-process. Is that ontologically driven? Like, or is that you mentioned that?
I mean, well, I mean, there's an ontology of how we represent the clinical trials, right? With the predicates that I use for clinical trials. And then there's a taxonomy component, right? Because we have UMLS with the more than several million concepts, right? That it can link to, right? And so I still use the ontology to find the right part of the clinical trials. I still use the taxonomy to get to terms that I want to relate to. And then ultimately I use the LLM, right, to fine tune and find actual answers or give answers to questions based on a very small subdomain. Oh, yeah, we're getting kind of in the weeds now. One little part called GraphReg, right?
Yeah. Well, it's funny. It comes up all the time. So it's not, yeah.
But for me, the neuro-symbolic AI is just about the very fluid interplay between a knowledge graph, symbolic logic, machine learning, and generative AI, right? But the use cases are almost infinite and it's really fluid. For example, we now have in our query language these things we call magic predicates, where you basically, instead of looking in the database, you apply functions. And one of our functions is to talk to our vector store. So for example, I want to match the term aspirin with other drugs in UMLS, right? So I now can say aspirin matches, and then I get a list of other medications, right? Or and medication dosages. Well, so that's part of a query, but a Lego graph can also use natural language to create queries for you, right? So you can say, okay, give me all the patients that use both ibuprofen and something familiar to aspirin. And so it will write a query for you, but part of the query is that calls this magic predicate again. So can you imagine? So you have a system that writes queries that uses itself, right, to do subqueries, right? So it calls itself within the query. But that magic predicate also uses Sparkle to do pre-selection. So basically, it's like turtles all the way down, right? You go from anyway, right? And it's very different types, and that's just completely normal for us now, right? To do this, we don't even think about it anymore. But this is an example. And another example is, so we always say I have medical databases, right? And I can do a prediction based on logic, right? I can say someone will get atrial fibrillation if, and then I have a whole series of conditions that you need to have, and then it's very likely you'll get AFib. But we have enough data that we can also build machine learning models, right? To given a sequence of events of a patient, I can say, hey, this person is going to get AFib in the next 3 months with the likelihood of say 70%, right? And a generative AI that at least 36 million PubMed articles plus 100 million other articles about healthcare, right, and patient care. And so it also has an opinion. So if I give a sequence of events of a patient to an LLM, it will tell me whether or not a patient is going to get AFib, right? And it will even give me an estimate. So now I'm there, and I have patients in my database with sequences of events. I can mix and match, right? Each 3 of these AIs can tell me something about the likelihood. And then the question, who's right? Which one? We even ask doctors to look at a sequence of events and what do you think, right? And so now neuro-symbolic AI is also that you have all these different predictions, and we found, right, and that if it's a rare disease, an LLM is way better at predicting what's going to happen, whereas for standard diseases, machine learning is way, way better, right? But symbolic logic is not doing bad for very well-known diseases, right? So it's a very interesting research domain, right? I have these 3 AIs, they all can predict, but when is what AI better? Does that make sense?
It makes perfect sense. And I'm wondering
Yep.
about the mix of just empirical study, against that, yep, you were right. Nope, that was wrong. This mix works better for this kind of condition or kind of pathology. But then I'm wondering also,
the interesting thing is you can just test it in the data, right? You have all the data available. So at any point in time for a patient, you can make 3 predictions and then you look what happened after that, right? So you can benchmark your own model.
oh, right, because you have all the data, the full course
Yeah.
of the patient history and their treatment and outcomes and all that. Okay, got it. Yeah, so you don't need to do that. And to what extent are physicians and doctors and researchers in the loop on that? Or is it just the fact that these AI agent tools are looking at their reports? Is that how they're involved, or is there human oversight at any point?
Well, I'm a strong believer of a human in the loop, right? I would. We have a very nice example of restaurant reviews, right? Where we look at we analyze restaurant reviews, right, over time, and we look whether or not the rating for the restaurants goes up and down, and can I find the reasons why the ratings go up and down, right? And if I make a mistake, put my LLM to get, say, some insight out of the text, who cares in the universe, right? Because I'm looking at thousands of reviews, and if I get a few wrong, who cares, right? But if it's about your life, right, a prediction, you better put a human in the loop, right? So a big hospital that we worked with had a model to predict whether or not a patient needs to be intubated, right? And so they had this beautiful model that could do the prediction with machine learning, but then the FDA would never approve of letting the machine decide whether or not you get a tube, right? What you do is you give the doctors a choice, right? You say, okay, well, the doctor could say, hey, it's not my patient, right? Like, okay, let someone else decide. Or I disagree with the AI, right? Or yes, I'll put an order in. And so they had a whole list of questions so that the human can make the decision. But there's many examples where we need a human in the loop. Like, for example, with complex knowledge graphs, and a human in the loop. We need a human in the loop to teach it how to write queries for us, right? So you say you build a complex knowledge graph. A developer would go around in the company and say, hey, what are all the things you want to ask of my knowledge graph, right? And then he starts writing, probably takes 2 weeks, doing example queries. And once you get enough example queries, you can train an LLM and you can do some intelligent prompting. And then it gets 99% of the queries right? When you just ask in natural language what you want from the knowledge graph, it will find it for you. It will write the query for you. It's every time when I look at it, I just can't believe how good it's gotten. But it's never 100% trustable, right? You still need an intelligent human looking at it.
Mm-hmm. And is it its ability to write the queries, or is that its main utility in that architecture, or is it because it's looking at so many examples? Well, like you said that before, though, that it depends.
Oh, no. Okay. So let's see how old-fashioned symbolic logic works together with generative AI, right? So we have a complex knowledge graph. The first thing we do is we ask Allegro Graph, build a shackle image of your knowledge graph, right? So instead of a human being writing shackle code to do shackle is kind of an alternative to building ontology, right? It's like a schema-based language that you can use to check the validity of your data. But you can also reverse engineer it. So basically, we don't write shackle anymore. We let the machine write the shackle, and then the human being looks at the shackle and says, do I agree with the shackle, right? And then you say yes, right? So now you pick that part. You let the machine write the shackle. And then when you ask the machine to write queries for you, in the prompt you say, okay, here's the shackle of my database, right? So now it knows the structure, right? And here are 5 examples that look very much like the thing you're asking, right? And by the way, here are some of the magic predicates that you might need for this query, right? And we do this in multiple steps. But the point being, it's not that you just ask an LLM that doesn't know your knowledge graph to create a query. No, you have to help it in every possible way. And part of it is you give it the shackle of your database, you give it successful examples, and then it writes queries. And if you like the query it wrote and the results you got, you store it as an successful example. So you teach the LLM, right? So the symbolic logic, the human, and the generative AI work together to become expert in writing queries automatically. Yeah, that is one of the million ways you can combine these technologies, right?
Yeah, and I guess we're all figuring that out as we go.
Yes.
Yeah.
Well, and for us, it's done second nature, right? We
Yeah. Well, that's it. Let me jump back to your old study of human behavior and cognitive science days, and how these architectures and the decisions about when to have humans in the loop, how and I don't want to talk about like AGI as like a thing, but like how truly helpful to humans and how close to human kind of reasoning are we getting with some of these? Like, if you really nail the architecture of some of these things you've talked about, it sounds like you can get pretty close to being a good diagnostician, or call center predictor. How does how much are you hearkening back to your old behavioral science and cognitive science days?
Well, I have you already interviewed Gary Marker?
Not yet. He's on my list for sure.
Yeah, you better call him. So he has a lot to say about reasoning, right? And of course, I'm a cognitive scientist. All I thought about when I was doing that work was thinking about reasoning, right? So, I mean, if even Bill Gates says that, hey, you need to combine generative AI with symbolic logic, right? And if the CEO of NVIDIA, right, is hiring knowledge graphs engineers, right, to combine LLMs with knowledge graphs, right? I mean, everyone in the industry now getting to the point where they say, hey, just using generative AI isn't enough. You need a structured companion next to the generative AI, right? Because in the beginning, I got so many customers that, well, we don't need knowledge graphs anymore. We can do it all with Gen AI, right? But that phase lasted only a few months, I think. And then that was over again. And then for a while, people said, well, at least we don't need taxonomies anymore, but we still need taxonomies, right? And so I see now, right, the cycle is turning, right, and people realize that I need a symbolic approach next to my generative AI, right? If I want to store the results, if I want to pre-select, I mean, there's so many ways where the two need to work together. Now, I didn't answer your question about reasoning, right? I think that we're getting very close to having really good reasoners in many subdomains, right? But they need to be treated. But it's going to be this agentic approach. This is going to be multi-step. I mean, if you looked at O1 preview and its reasoning, right, you see 20, 30 sub-questions it's asking, right, just to make sure it covers the whole thing, right, and then still can get it wrong. But yesterday I tried to get O1 preview to write a Prolog program to do something complicated, right? And after about 20 minutes, I gave up because it just couldn't do it. And I, as a human being, could do it. But the point was, I was even thinking, should I write an article about this, right? I gave it every help I could, right? But it doesn't, when it tries to write, say, Prolog programs, right? To me, it feels like it doesn't really understand Prolog, right?
Is it just because there's so many fewer examples of that than Python or JavaScript, or?
Yeah, but I'm reading also a lot of literature about how people use Python in production, right? And instead of getting 10 times better, you get maybe 10% better, right? And then yesterday I actually read a great article about that if you are an experienced Python programmer, it can be an incredible productivity tool, right, to use it. But if you are a beginner Python programmer, then you might accept Python programs that are just plain wrong, right? And you don't get it. So you still need to be a really good Python programmer, and then it's a fantastic help. If you are a beginner, you just don't learn the language like you should. At least that was the opinion of the author, and I really, really liked his. I can send it to you later.
I would love to include that in the show notes. That sounds fascinating. And it kind of, there's some kind of like matching going on there with level of like how much you can get out of these tools depends on how much you've got in your head already. Is that accurate? Yeah.
Absolutely, yeah.
Hey, Jans, I can't believe it. We're coming up close to time. But before we wrap up, is there anything you want to revisit from the conversation or just make sure we share before we close?
Well, apart from saying, if you have anything, I make a plug for myself, right? If there's anything where you need a combination of symbolic logic, machine learning, and Gen AI, right? Then come play with us.
Well, yeah.
That's all I can say. I mean,
my intent in doing these is to advance practice, but some people are already advanced as to what we were just talking about. Yeah. You've got more of this in your head. So, that's perfectly legit. Hey, and if folks want to connect with you or follow you online, what's the best place to find you?
Well, cut me email at GA, my initials, at franz.com.
Great. I'll put that in the show notes as well.
That's great. Thanks.
Yeah. Thank you so much, Jans. I really enjoyed the conversation.
Okay. Well, it was fun to do. And I hope to talk to you again. All right.
For show notes and to sign up for our newsletter, visit our website at knowledgegraphinsights.com. And please rate and review us on your favorite podcast platform. Thank you for listening.